here. We're going to start this with section 2.2, which is called Graphs of Equations in Two Variables. This book loves huge titles. Don't let that scare you. All this means is that we're going to be dealing with two variables, usually x and y, just like you're used to. So typically when we're looking at something new, we like to start with an example that's easy to work with. And a lot of times we'll be working with linear equations because the math is simple and you should be familiar with linear equations coming into this class. So for example, you might recognize a linear equation as ax plus by equals c. That would be a linear equation in standard form. Or y equals mx plus b. That would be a linear equation in slope-intercept form. So that's two examples of equations in two variables, and we'll look at a lot more as we go through the class. So the first thing that we're going to start with is a little bit of the vocabulary that they use, because a lot of times the most important thing is understanding what they're asking you. So they may ask at different times during our lessons for you to determine if a point is on the graph. Okay, so that might be one way that they phrase an activity. Another way would be to determine if a point satisfies an equation. Okay, satisfies an equation. Satisfies might be kind of a weird word if you haven't heard that in terms of using it in a math class. Another way might be to determine if a point is a solution to an equation. All right, now that one's a little more familiar. Determine if a point is a solution to an equation. We know what to do with that. So let's say we have a question and they want to know, is 3,1 a solution to 2x minus 3y equals 3. Okay, is it a solution? So this is something that you're familiar with, maybe not in these terms, but if you are given an equation and you solve it and you want to know if your answer is the solution, what do? You plug it back in. So that's what they're asking you here, is they're asking you to plug this in. We've got an x and a y value, and we're going to plug it in and verify that this is a solution. So when we do that, we plug in 3 for x, we plug in 1 for y, and we check to see if this comes out to be a true statement. So if it's a true statement, then we know that yes, it is a solution. All right, so knowing that something is a solution is the same as saying that it satisfies an equation. It's kind of weird terminology, but that's what satisfies mean. It means that it makes it true. And that's the same as saying determine if a point is on the graph. It doesn't literally mean that you have to graph it and try to figure out if that point is on it. If a point is on the graph, that means that it is a solution. Okay, so if it says determine if a point is on the graph, that does not mean that you need to graph it. And in fact, that would be one of the least desirable ways to do it, because when we graph by hand, our solutions aren't always exact, because we don't graph perfectly by hand. Okay, so let's look at another one. Let me erase this part of it. Okay, so similarly, let's say the question is 2 negative 1 on the graph of 3x minus y equals 4. So this is our next question. Is 2 negative 1 on the graph of 3x minus y is equal to 4? So this is the same as saying, is 2 negative 1 a solution to this equation? So we work this the same way. We put in our x and our y into the equation, and we check to see if it's true. So 3, 2 minus a negative 1 is equal to 4. So 3 times 2 is 6. Minus a negative 1, remember that's the same as adding a positive. So is 7 equal to 4? No. So no, it is not. It's not on the graph, and it's not a solution. Okay, so that's just a little bit of terminology. I know you guys know how to plug in a value and see if the answer is true. So this is just a little difference in the way that we're phrasing the question. Okay, so the next thing that we're going to talk about is we're going to talk a little bit about graphing. We're assuming that you're coming into this class with some basic math skills and with a basic knowledge of how to graph lines, but not really much else. So some of what we do should be review for you. And if it's not, that's okay, because we'll go from the beginning. But we're going to start with the most basic graphing technique, and that's graphing by plotting points. So when we get to something that is not familiar to us, to start with, that's going to be anything other than a line, we're going to graph by plotting points to see what's going on, because we don't know anything about that equation. So when we graph by plotting points, there are some things to remember. One is that it's the least accurate. Like I just mentioned before, when we graph by hand, we're relying on our own scale, on our own ability to draw, basically. So this is going to come out to be the least accurate. It's also very time consuming. Okay, because we don't know what's going on, we have to plot a lot of points depending on what the function is. So really, if you don't know anything that's going on, you should plot a lot of points. If we can combine it with a little bit of what we already know, then that helps, and it cuts down on the amount of time that it takes to plot those points and to pick X and Y values. The reason why we do this is that it's good when you don't have any other information. Okay, so it's good when you don't have any other information. So like I said, when we come up against an unfamiliar equation, an unfamiliar function, we're going to plot some points so we can see what's going on, because we can't assume that we know anything about this. And then once you have some information, it's better to use that information than to go back to plotting points. But plotting points will always be our fallback point for graphing. Okay, so for example, let's start off with a linear equation. Again, these are the easiest to deal with. You should already know how to graph this. You should know that the y-intercept is -1, so that means we start at -1, and the slope is 3, so we go up 3 over 1. So you should kind of be able to picture that in your head, what this is going to look like. But let's pretend that this is an equation that we don't know anything about, and we're going to plot points. And all that means is that you set up a little table, and you find some points that you can graph to get this picture. So let's say that we know this is a line, but we forgot about slope-intercept form, and we just need some points to figure out where that line is. We know that we need at least 2 points for a line. Let's go ahead and graph 3. The more complicated the function, the more points you have to graph, and the longer it's going to take. But for this one, we know it's pretty simple. So let's just pick a few numbers. So let's do -2, 0, and 2. That gives me a negative number on the left side of the graph, 0, and a positive number on the right side of the graph. And all we do is we plug this into our equation over here. So when we plug in -2, we're going to get -6 minus 1 is -7. And when we plug in 0, we're going to get 0 minus 1 is -1. And when we plug in +2, we're going to get 6 minus 1 is 5. Oops, sorry, I forgot to fill these in. Okay, so we get our points, and we plot our graph. So mine's probably going to be even a little bit messier than normal, since this tablet's a little bit hard to graph on. But hopefully we can get a good picture here. Oh, 2, 4, need to go a little bit lower. Okay, so we've got -2, -7. We've got 0, -1. We've got 2, 5. Okay, and we can see that this is a line, and we knew that it should have been a line, so having a little bit of knowledge with our plotting points helps us a lot, because if this was complicated or we knew nothing about it, we would have to plot a lot more points. So let's go ahead and draw this in. Okay, that's about as good as I'm going to get with the tablet. You know they should be going through these points. Okay, and there's our line. So whenever we say plotting points, this is what we mean. Set up a little table, pick some X values, and then graph what you get.